Welcome to Module 2.4. We'll talk a little bit more about confinement techniques, but this time we'll talk about an idea of jailing applications within a specific jail environment or a restricted environment beyond which this application cannot access anything or cannot communicate with other processes which is not within that environment. So, this is originally started in 1982 by Bill Joy, who was trying to compile something and he had this specific set of include directory, and in order to make sure that the compilation does not pick up some include files from another include path, he tried to create an environment that cannot see anything outside the specific boundaries that is set by some programmatic technique. And he created this idea of change root system call, and this change root basically what it does is that let us say you would say change root /temp/guest, and then you do su guest, then the root directory for this user will be /temp/guest. So, what will happen is then if he calls open /etc/password, it will be replaced by /temp/guest /etc/password, and application cannot access files outside jail. So, in the beginning when there were no HTTP or web and stuff, people used to use FTP servers to put out their publications and so on for others to come and download, and these FTP servers would be actually running on some of the few servers that people used to have, and therefore if there is any bug in the FTP server, then the worry was that somebody could actually take control of the entire server. So, therefore this change root jail was actually quite a bit used in the FTP servers in the early days. However, it has been noted that change root is not a security mechanism. It was a confinement mechanism for reducing the visibility of parts of the file system to a specific program or specific user, but it is not a full secure environment, and actually the originators of change root has said so many times. Now, when you actually do a change root, in order for the user to be functional, you have to copy many different system files within /temp/guest. For example, if you have a user bin, if you have a /bin, all those things have to be copied over to this underneath /temp/guest, otherwise the user won't be functional or his programs will not be able to access those header files during compilation and include files during compilation and linking and so on. So, in order to make it easier for system administrators to create this environment so that they do not have to manually copy and forget some of the important directories to be copied onto the jail, there are programs. For example, this jailkit program, where it has multiple different commands which creates the change root jail environment, then it checks for certain security issues within the jail environment. It basically creates a restricted shell within the jail and so on, and you can actually access, you can actually download one of these jail kit environments, and this is the way for you to actually try it out, and therefore you can create your jail environment without having to worry too much about copying and restricting and so on. Now, there are many ways to escape a jail. For example, if you are not careful in designing your jail environment, then there may be a relative path escape. For example, somebody if the user is aware that he or she needs to go to /etc/password for malicious purposes or for some other purposes, if they do a relative path specification of the file, then they might be able to get out of the jail unless it has been expressly forbidden. And actually in Ultrix 4.0 there was a very interesting bug, and that is very demonstrative. So what it allowed a jailed program to actually create a jail environment within itself. So what a jailed application can do is, let us say it creates a dummy file within its own environment, let us say /aaa / etc / password, then it writes the entry, the normal entry in the password, and look here that the password here is basically no password. Then it creates this directory /aaa /bin, and then then it copies the shell onto that, and then it runs change root to /aaa. So now if it was already in, say, let us say temp guest environment, and then it has now AAA, now its root environment has become this. So when it now refers to / etc / password, it would basically going / etc / password here, and there is a password file which has entry for the root. So therefore when it does su root, this the SU will actually look for the password file at / etc / password, but the SU does not know that it is a jailed environment where it has been relativized. So now we are going to now it is going to read it from this one and then allow the user to become root. So that means that one lesson from this Ultrix bug was that change root should not be allowed to run by a non-root user. So if you are already a jailed user, you should not be able to run change root. So these are some of the issues that come up in this change root jailing environment. So there are many other ways people have found to escape the jail. For example, many applications can directly access the raw disk, and once it accesses the raw disk, it can actually change files, and therefore it avoids the entire file system, and therefore the jail restrictions do not work. It can send it can attach itself to a non-change rooted process and thereby gain access. Obviously if you reboot the system, or if you you are allowed to bind to a privileged port, you might do a lot of things to get yourself root access. So then people started thinking about how to create this confinement environments without having the shortcomings of the change root jail. So they started thinking in terms of what we nowadays see as virtual machines. So in FreeBSD jail, you basically create this address space partition, and then basically they become individual virtual machines. And even before virtual machines were popular, this was used for various types of servers like mail servers, and FTP servers and so on the same machine. And obviously the mechanism for creating FreeBSD jail, since it is much more complex, there are commands. So in FreeBSD you will find jail command. It will get it will take certain arguments like jail path, host name, the IP address, command, and so on, and you will be I will be sending out a document that gives you all the detail about how to create this FreeBSD jail, and also how to get out of the FreeBSD jail. People have figured that out as well. Now FreeBSD jail, as I said, is one of the precursors of today's virtual machine. So we will be looking into the virtual machine based isolation in the next class, but what we are going to see here is that a little bit of peek into what that involves. So normally there are three types of ways to do this, creating within one server or within one system, creating multiple different virtual machine type of environment, where each virtual machine will run a specific OS or specific application. So one is to do hardware emulation. So hardware emulation, where you completely emulate a full hardware in software, and then you can actually do boot an operating system on that, and then start applications on that booted operating system. This is used quite a bit in the computer architecture research, because there actually if you can emulate the hardware, then you can also try various cache, let's say cache policies, various ways of creating file system changes in the actually architecture to see whether that gives rise to a better performing architecture and so on. But as far as isolation and confinement is concerned, this is a very expensive and low performance method, so this is not normally used. Native virtualization is basically what we use most of the time, such as in VMware server or Oracle VirtualBox and things like that. Here this is also called a type 2 hypervisor or type 2 virtualization. It allows partial access for the guest operating system or the virtual machines to the hardware itself, and some of the hardware are partially emulated. So you can load a full operating system without any change to the operating system, and then you can actually use multiple operating system on the same machine or same server. On the other hand, para-virtualization is actually is where you actually make change to the operating system a little bit in order to have higher performance and efficiency, and there the idea is that you are going to have more access to the hardware directly, and this gives you slightly higher performance, although this has been discussed quite a bit in the literature as to whether this is really that high a performance compared to native virtualization. So for example, VMware ESX server or Microsoft Hyper-V are examples of para virtualization. Now the reason why we are going to this virtual machine based isolation eventually is because jail is not, first of all, that secure, and second is that not all programs can run in a jail. For example, web browser or a mail client, they require to access the file system so that it can attach files and things like that. So creating a jail environment for running this client side applications, not going to work. Whereas if you are running a server like a web server, then it runs okay on a jailed environment. So change root and jail also has the problem that the policies, security policies are kind of coarse grained. So once you create the jail, any part that is not allowed within the jail is not accessible. So there is no fine granularity based access control. So as I said, that it's not going to work for web server or a client, mail client, and also it does not prevent malicious applications to be installed in the jail and then use one of those techniques that we discussed earlier. I mean, we didn't discuss in full detail, but I would put up some literature on that. But there are ways to actually escape the jail, and then if you have a malicious app, then it will certainly try to escape the jail or try to crash the operating system, creating denial of service and so on. So the next module will be based on the idea of a system call interposition, which is basically another way of creating isolation by not allowing an application to access everything that it wants, and that will be another way of confining a process from doing malicious activities.